So friends, let us take a very simple example here to understand this concept. So this is now mass m1 and this is mass m2 and this is the center of mass. All right, so this is the center of mass. Okay, now if this distance is, let us say, r1 and this distance is r2, so you have been given this distance, these distances in the equation, that is m1 is at r1, m2 is at r2 from center of mass. All right, so the question is, if m1 is shifted by a distance d towards the center of mass, m1 is brought here, m1 is brought here, it is shifted by a distance d, then by what distance m2 must be shifted, by what distance m2 must be shifted so that the center of mass is, it remains undisplaced. I mean, it remains at its own position. The question is, if m1 is shifted by a distance d towards the center of mass, then by what distance m2 must be shifted towards the center of mass so that the center of mass remains at its own original position, does not change its position. So friends, how to do this question? All right, so we can do it by 2-3 different ways. So first I'll discuss a very simple method, that is we know that the center of mass divides this in the ratio, inverse ratio of the masses, right? In the inverse, so we know that the center of mass divides the distance between the two masses in the inverse ratio, right? So we know that m1 r1 will be equal to m2 r2, right? So if we have shifted this mass by a distance d, then the new distance will be r1 minus d. So the new distance is r1 dash and this should be equal to m2 into r2 dash, right? All right, so this is m1 into the new distance r1 dash is now r1 minus d, and friends, r2 dash is going to be r2 minus x, right? So this one is going to be r2 dash, so that is r2 minus d, the new distance of the mass, because m2 also has to be moved. So m2 is moved from its original position to this new position, right? So this is going to be m2 into r2 minus this is not d, this is x, which we have to find out. So this is x. All right friends, now let us simplify this. So this is going to be m1 r1 minus m1 d is equal to m2 r2 minus m2 x. So we know m1 r1 is equal to m2 r2, so this cancels out and we have m1 d is equal to m2 x, and from here we have got x. So that's the answer. So m1 d by m2, that is the answer we have got. So if we have shifted this mass by a distance d, then we'll have to shift this mass by distance x, which is equal to m1 d by m2. Then the center of mass remains at its own position. All right, so we're also going to discuss this from another perspective, but little later. So I hope you've understood this concept.